Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we'll continue from our previous topic, functional properties of egg. First of all, we'll discuss how egg helps in shelf life extension. Freshly baked grain-based foods tends to lose their desirable tender crumb within a few days. An increasing number of commercial bakeries are looking for more natural methods of extending shelf life, and egg products can maintain quality throughout the anticipated shelf life of the baked goods. Staling, drying out, or retrogradation is the result of an irreversible process that liberates water and collapses the starch molecule. The starch chain swells with the water when bread or another baked good is heated in the oven. As it cools, the starch chain starts to lose its moisture as the water migrates to other part of the product and eventually evaporate, leaving the starch molecule to collapse. Then the crumb degrades and leave a dry mouthfeel. Egg yolk contain less than all natural emulsifier with one end that dissolves in water and the other end that dissolves in oil. Uh, this emulsifier lodges in the space between the highly branched starch chain to retard the onset and the rate of firming in the baked goods that occur at this age as the product ages. In addition, egg yolk has a beautiful yellow hue due to xanthophyll content, leading the baked good a richness in terms of color, which contribute to perceived quality and freshness. Egg white contain a unique protein found nowhere else in the human food supply and traps air to create a foam 6 to 8 times greater in volume than the unwhipped egg white. The protein helps to aerate the baking mixture to create a volume and springiness which suggests the freshness to the consumer. Egg also coagulate, which is the transformation of liquid egg into semi-solid or solid matrix, binding the water and in this way also contributing to the product shelf life. Tenderization or texture development. While flavor of a food is important, the texture of a food is equally important. Whether a food is crisp, creamy, or chewy, the sensory experience of chewing and swallowing helps the consumer to enjoy and even identify their favorite foods. Texture is a part of food rheology, even though textural awareness can be subconscious. The touch is the primary sense used to figure out the texture, but kinesthetic, that movement and position, sound, sight also is involved. In baking, in particular, the texture of a loaf crumb is a major quality factor. The texture manifests itself entirely through the sense of touch. One reference lists the distributor for the crumb that covers a range of smooth, velvety, silky, soft, and elastic, or harsh, rough, crumbly, lumpy, coarse, or doughy, depending upon the texture. The grain or cell structure of the crumb greatly influences the texture. Finely thin-walled, uniformly sized cell product will be softer and more elastic texture than the coarse, having open and thick-walled cell structure. Even crumb color itself is a perceptibility influenced by the crumb grain size and fineness of and the uniformity of the cell structure. The finer the grain, the brighter the brighter color crumb as perceived by the human eye, with the grain or the cell structure exposed when the loaf is sliced. Therefore, both crumb size and color make an impact on the final product texture and acceptance. Maintaining anticipated texture for manufactured food products could be essential to successful sales. As quoted from Food Navigator, consumer associated specific texture with certain foods, and these ideas are often strongly entrenched. They expect cookies to be dry and crumbly, not soft and moist. Food that do not conform to these ideas could be best seen as gimmick or the boast or that evoke disgust. Egg helps to set the structure that aid with the baked good texture. In fact, the uniformly open cell structure and fine crumb of many baked goods is due to the coagulation of the egg protein during baking. Fats in the yolk produce a tender, soft crumb in the baked goods such as muffins, cakes, and retard the onset and rate of firming that occur with the age. Egg protein within certain food matrices can help to maintain the product moisture by binding the water in the structure and to prevent it from drying out. In doing so, there are textural benefits such as desired level of chewiness that help uh, the given product and improve mouthfeel. Egg yolk contain lecithin and other phospholipids that act as natural emulsifier. With this emulsification property, a benefit to uh, aspects of the finished product texture. Emulsification action of egg yolk help to produce the smooth butter and subsequently contribute to the volume and texture. The egg as emulsifier interact with gluten to strengthen the protein network to create a desirable texture. Emulsifiers improve gas bubble stability for a light, tender, and moist product, retarding the staling. Lecithin from the egg, in addition to increasing fermentation tolerance in bread and allowing it to exhibit better dough machinability in commercial baking, also produce a butter crumb color, tenderize the crust, and lends to the product a smooth texture with maintaining grain uniformity and lengthening the product shelf life. Whipping ability. Again, egg white can be whipped into a foam for aeration to improve the product texture and appearance. Egg product whippability plays a role in baking and frozen desserts such as ice cream in addition to certain confections. Various type of egg product display varying levels of whippability. With the difference between egg white and whole egg and egg yolk, the dried egg also perform in different manners than liquid or frozen in terms of whippability. Pasteurization, a process applied to all further processed egg product, does not impact the whippability. Egg white, for example, is very stable in a dry state and its whipping properties remain unaffected unless excessively high temperatures are applied. However, the whipping properties of egg product containing yolk uh, do wittiness a lose in efficacy when in dried form. So, refrigerated and frozen are recommended for certain applications. Dried egg white solids, if chosen for application, often are reconstituted prior to use. Proper mixing procedure help to minimize the foam volume. Proper mixing procedures help to maximize the foam volume in commercial practices. Egg white solids perform well with the continuous batter mixing systems. When whipped, the proteins within the egg white unfolds and denatures to form a relatively stable form structure, useful in angel food cake or as well as sponge cake, certain confections and other baking applications. Whippability has a bit of a different meaning when it comes to ice creams. Whippability refers to the whipping quality of the ice cream mixture itself. The proper emulsifiers such as egg yolk result in the reduced air cell size and a homogeneous distribution of air in the ice cream structure. The lecithin protein complex in egg yolk solids improves the whippability of ice cream, also lending it to be more dry in appearance and smoother body and texture and a slower meltdown. According to a study, egg have a pronounced effect in improving the body and texture, have almost no effect on the freezing point and increase the viscosity, all positive benefit in terms of ice cream manufacturing. There are mixed calculations that help the formulate ice cream and frozen dairy desserts to determine the percentage required for the various ingredients. The egg yolk solids are especially desirable in mixes in which butter or buttermilk is used as the main source of fat. Egg yolk and whole egg improve the rate of whipping more if they are sweetened within 10% sugar or corn syrup before they are frozen or dried. Ice cream, according to US Code of Federal Regulation, can be called as custard or French if the egg yolk content is at least 1.4%. That's all for this topic. Thank you so much.